Hello and welcome to Fast Builds and Integrating Libraries using CMake and Ninja with C++ Builder. I'm David Millington, that's me on the bottom right. My email address is david.millington@embarcadero.com and you're always welcome to email me. Now during this webinar, the only audio will be myself right until the end. And at the end we'll have live Q&A. So please feel free to ask questions. There's a Q&A panel and you can type in questions at any time. And during the webinar, we will type answers to you. But at the end, we will go through that and we'll actually go through and discuss some of the questions and read them out and answer them verbally for everyone who's listening. So please ask as many questions as you want. If you're wondering something, then other people are probably wondering the same thing. So type it in and we'll answer it. As I said before, my name is David Millington. I'm the C++ product manager at Embarcadero. That means I look after C++ Builder. And my email is david.millington@embarcadero.com. It's always fantastic to hear from customers or anyone, in fact, so please feel free to drop me an email. Now we're going to look at a few things today. We're going to have an overview of CMake and Ninja, what they are, why they're important, why you should use them, how they work, that kind of thing. Then we're going to see how to use CMake to build an existing C++ Builder project. So if you're a C++ Builder user and you have a C Builder project and you want to use CMake with it, how do you do that? And we'll discuss that and also have a live demo with an existing application. But then we'll talk about how to use CMake to build external third-party projects that were not written with C++ Builder specifically in mind, but you can take those and using CMake build them easily with C++ Builder. And again, we'll have a live demo to show how to do that. Finally, we'll have questions and general wrapping up. So let's get started. So the most important question is, what is CMake? Well, CMake is a cross-platform project descriptor / build system. People call CMake a build system. It's not really true. It's more like a project description. So if you're used to using C++ Builder or Visual C++ or some other C++ IDE, you'll be used to the idea of a project file, some kind of file somewhere that lists all the C++ files that go into a project and then lists a whole bunch of compiler settings and that kind of thing. Now, a CMake file is a compiler agnostic and therefore cross-platform version of that. It describes the files and settings and that kind of thing used to build a project. And that's only useful when you can actually use it with a particular concrete compiler. So CMake takes that CMake list.txt file, which is the project description, and converts that into a format for any platform native build system. And that's something that knows how to invoke and use your compiler. So a traditional example is Make. And in this webinar, we're going to be looking at Ninja, which you may or may not have already used, but is a very, very cool build system. And of course, it can use others as well. The key things here are that it's compiler and platform agnostic, and it builds using your own setup, so you can describe a project once and you can build it anywhere. And for that reason, the vast majority of open source libraries use CMake. So what about Ninja? On the previous slide, I said that CMake converts the CMake list.txt file into a format for any platform native build system, and I use Ninja as an example. And so Ninja is a build system. It's lightweight, it's fast, and does parallel builds. So Ninja is the thing that actually invokes the C++ Builder compiler. So when you use the combination of CMake and Ninja with C++ Builder, you get a couple of key things. The first is that you can build your own C++ Builder project on the command line parallelized. Now we already have parallel building within C++ Builder, but Ninja is also a very neat way to do it. And Ninja gives you roughly a linear speed increase with the number of CPUs. So 2 cores means that you'll build approximately twice as fast. 4 cores 4 times as fast. I'm sure you can see where this is going. It's fantastic. You can even deploy to your mobile device from the command line. So if you have, say, an iOS or Android application and you build it with CMake, then you can go through the entire process of starting with the source code, talking to the platform assistance server, right through to deploying it on the device itself from the command line. That's extremely powerful. So that means it's great for build speeds. It's also great for build servers and for automated testing. The second thing is that you can easily build any third-party C++ library with CBuilder. So it doesn't have to come with a .cb project, a C++ builder project file. You can just download a third-party library from GitHub or anywhere else on the internet, build it, and then you can link it into your project. Now, this is huge for taking advantage of the wide C++ ecosystem. There are many libraries out there, and now you can easily use them all. So how do you use CMake? Well, the CMake project file is straightforward. It's called CMake list.txt. And you can see on the right, I have a diagram of the stages of building the CMake and Ninja. We'll go through these in more detail, but roughly, CMake reads the CMake list.txt file. Then it generates other build formats, such as the Ninja build format, and then you build using that. So the first step is to read a CMake list.txt file, and the rest of the slide is an example of a very simple but complete CMake list.txt file. It contains 4 parts: the minimum version required of CMake, the name of the project, so here project and in brackets mazes, that means that at the end we're going to end up with a mazes.exe. The third item is setMBT_target. And that's our extension. So CMake has a large number of macros, effectively functions, that you can invoke and call. setMBT_target is one of them that we've added, and that allows you to specify various C++ Builder specific linking options. We'll go into this in more detail in a few minutes. This one simply says to link against the FireMonkey framework and link against the dynamic runtime. Finally, there's the add executable macro, and this says that we're building an executable as opposed to, say, a static library or shared libraries. And this says that for the mazes project, it contains those CPP files which you can see in italic. So it's really quite a simple format. It's just a plain text file that's easily editable. There are a number of macros or functions which you can call to set particular behavior. Of course, there are environment variables that you can check. You can have if statements. It is perhaps a scripting language is a good name for the CMake language, but it's quite straightforward to read and to write. So the second step in the CMake process is turning the CMake list.txt file, which is your project description, into something that your favorite build system can understand. So we're going to use Ninja, and we're going to also use the C++ Builder compilers, and Ninja is going to invoke those compilers. So you can see a couple of command lines on screen. If we look at the top one with a couple of -d parameters, this is for building for Windows, and you specify the compiler that you want to use. Here it's BCC32X. You can also use BCC64 if you want to build for Win64. The -g Ninja specifies that you are using the Ninja generator. And the second command line there is slightly different. When you're building for Windows, whether it's Win32 or Win64, you're building for the current platform that you're running on. But when you build for iOS, you're building for a different platform, so you are cross-compiling. When you're cross-compiling, you use a slightly different command line, and you specify a toolchain file. We provide toolchain files for iOS and Android. The example on screen was for iOS 32, and of course you can use iOS 64 as well. And that just says to use our Embarcadero iOS configuration. And of course, it too has -g Ninja saying to generate Ninja build files. So that's pretty straightforward. Either you're building for Windows or you're building for another platform. And if you're building for Windows, you just say which compiler you want to use. If you're building for another platform, then you use one of the toolchain files that we also provide. Finally, you run that build system, in our case Ninja. Now Ninja is extremely lightweight. You don't need any command line whatsoever. You just type Ninja and press enter, and that's it. This is an existing C++ builder application. It's not particularly large. You can see it has 5 or 6 different C++ files, but it's enough to demonstrate a real-world, non-trivial app. Now if we have a look at the source, see of course we have a normal C++ builder project, but we also have CMake list.txt. And this is the same CMake list that was in the presentation earlier. To use CMake, we open a command line window and type CMake with the defines to use the C and C++ compiler as using the Ninja generator. Now when I press enter, CMake is going to analyze the CMake list.txt file, run a few tests on the compiler to make sure that everything is working as expected, and create a number of output files. That could be cache files for CMake, so the next time you run it, it just needs to update rather than reanalyze everything, and it will be the final Ninja output. So let's run that and see what happens. Only took a few seconds. Now we notice that in the source folder we have a CMake files folder that just contains a whole bunch of cache CMake information, and we also have a couple of Ninja files. Now we don't even need to look at those because Ninja is very simple. It doesn't require any command line flags. You just run it and it will look for those files automatically. Now this is where it gets particularly cool, because Ninja is a parallel build system. So I'm going to open Task Manager here so we can see Ninja actually building in parallel. So when I run Ninja from the command line, it will find those Ninja files that CMake generated. And just as a reminder, they are the CMake list file transformed into a different build system, into a description for a different build system. And then it will execute those, and it will create a final executable. So you can see here immediately that we have about 6 BCC32X processors running. And if you look back at the command line, you can see on the bottom left a counter, 3 out of 7. Ninja is building in parallel. It serializes the output from multiple processors. And you can see it's done. It didn't take very long, but it was approximately twice as fast as building within C++ Builder because this virtual machine has 2 virtual cores. Now if we go back to the CMake list.txt file, we specified that the project, the executable, was going to be called mazes. So we should expect now to find a mazes.exe. And if I run that from the command line, you can in fact see we have a running FireMonkey application. Going back to the CMake list.txt file, I do want to talk a little bit about some of the Embarcadero specific macros that we've added. setMBT target here is the most visible one. Now we have very extensive documentation on our DocWiki site, and I would encourage you to read that. It has far more detailed information on using CMake than can be given in just a webinar. The page here shows you how to install CMake in Ninja, how to use it, how to build with it, and includes a number of example CMake lists.txt files for very simple VCL apps, FireMonkey packages, shared libraries, static libraries, that kind of thing. And you can use those as a basis for creating your own CMake list.txt files. It also talks about C++ Builder specific support in a CMake list.txt file. The first item is the setMBT target macro that we just saw, and that takes 4 possible parameters: FMX, VCL, package, and dynamic runtime. And these specify whether you're linking in against FireMonkey or VCL, or linking against the dynamic runtime, or if you are creating a package. CMake by itself has the concept of a shared library, so a DLL, but if you want the output to be a package, which is a special type of DLL that's unique to C++ Builder, much like a .NET assembly, then you should specify that you actually want a package like so. Then, especially for iOS and Android, but also Windows, there are a number of other macros and variables available. And for iOS and Android in particular, these are very useful to specify all the information that would normally be in a C++ Builder project file, but that you need in order to deploy and to build a proper final application. So you can see an example here, specifying things like the iOS bundle identifiers, the device family, and so forth. And all of this will make it into the iOS applications, info.plist, and so forth, and the same thing for Android. If we click the macros and variables link here, you can see that we have a rather large page detailing everything that you could want to use. So documentation is highly detailed, should contain everything you need to get up and running to build Windows applications, iOS applications, Android applications. It's really useful to note that you can deploy as well right from the CMake build script. So if you have an iOS or an Android app and you want to go all the way from building to getting it on the device, you can do that through CMake. So that was using CMake with an existing C++ Builder project. But we can also use CMake with C++ Builder with existing third-party libraries that weren't written with specific C++ Builder support. Now there's huge value in bringing in any third-party library. There's a lot of third-party C++ code out there, a lot of open source libraries, and you can now bring in any of those and use them with C++ Builder. So as an example, we're going to use Google Test because it is useful and common. Download it from GitHub. You need to tweak a few macros to make it aware of C++ Builder. Typically you find in third-party code that there are two assumptions. That if it's Windows, then it's using Visual C. That's not always true. And that if it's Windows, then you need specific headers, and there are minimal differences there. And it's very easy to adjust both of those. Usually when you build, you'll simply get a compile error, and when you track the cause of that error, you realize you just need to define a particular macro or tweak something. Pretty easy. We'll have a look at that. Then you just build with CMake and Ninja, and you'll get an executable, perhaps, or here with Google Test, we will get a library, and you can just link that into your project with pragma comment lib, just as you might with any other library. And this shows how easy it is to take a effectively random third-party C++ library off the internet. It's never been designed to work with C++ Builder specifically, and easily and trivially make it build with C++ Builder. Extremely powerful, huge value to you if you want to do this, to bring in other libraries into your applications. Now let's look at a third-party C++ library that was written without any specific C++ Builder support. We're going to use Google Tests and Google Mocks, that is, Google's unit testing framework. And I just grabbed this from GitHub, more on that in a moment. Now this contains a CMake list.txt file. It contains a few more macros and options than we've seen before, but is fundamentally fairly similar. The most interesting thing is the use of add subdirectory here. So we're going to build with build gmalloc turned on, and that means that this add subdirectory line will be run. So what does that do? Let's calling add subdirectory for Google Mock. Let's go have a look, and we can see that yes, there is in fact a folder called Google Mock. And if we look in that, it has its own CMake list.txt file. So this is an example of a slightly more complex CMake list setup. You can also have ones where a single CMake list.txt file has information for a number of projects. Now, in terms of GitHub, Google Test was written without any explicit support for C++ Builder, and if you just get it straight from the Google repo, it may not build. So we've done a few things here in this particular repository, and there'll be a link at the end to enable this to build. Typically what you find is that there are macros in source code that check for Windows and then do something, such as including a particular header or calling a particular method, or check for Visual C++ and do the same thing. And so you need to look for those and add support for C++ Builder. The one I have highlighted here is an example where we've added a couple of lines for code gear C __ macros. That's defined when you're using C++ Builder. And here we're calling putenv without a preceding underscore. So it's very simple. There's not much to change. You just need to go through and make sure that you change things appropriately. In total, there were 4 changes made to support Google Test, which is not bad. Let's go back here and we can use the same command line that we used before. Building for Win32 at the moment, so we're using BCC32X as the C and C++ compilers, and again generating Ninja build files. Let's run that. It has generated the Ninja files, which you just saw pop up in Explorer below the command window. Now if I run Ninja, you can see a number of BCC32X processes. The number is limited, so there are 11 steps if you look at the bottom left corner of the command prompt window, but we still only have a maximum of 6 instances of BCC32X. And it is built. So if we now go back here and look in the Google Mock folder, you'll find a couple of lib files that were just built. And you can now link those into your C++ Builder project using something like #pragma comment lib, just as you might normally. So that's a fantastic example of taking a completely random but useful third-party C++ library, making a few tweaks that you might need to make, but are straightforward and easy to ensure that it works with C++ Builder, and then without modifying the CMake list.txt file whatsoever, running CMake and building with Ninja to build with C++ Builder and get some compiled results. So CMake is really very easy to use. There are a few key takeaways. First, you can easily pull in third-party libraries. The vast majority use CMake. It's really powerful and useful for you to be able to pull in any third-party code to your application. Any of the C++ libraries that are out there, you can download them, tweak them, build them, easily, straightforwardly include them in your C++ Builder application. The second is that you can build fast. Ninja is lightweight and uses parallel builds, and it scales with the core count. So if you have a build machine, or even if you're just building locally, Ninja is a fantastic way to speed up the often famously slow C++ build time. And save time is save money, save effort. It's very valuable to you. The third is that we have command line C++ Builder support for Windows, iOS, and Android for all the businesses that we support. And you can even deploy to the device. So the picture here is that it is comprehensive. So you can pull in third-party libraries, you can build them fast, and you can build wholly from the command line, starting from the source all the way to the device. And with that, we'll move on to questions. So just as a reminder, there is a question tab in the webinar software. Please type in the questions that you have and we'll answer them live. So we do encourage questions. It's fantastic to get your feedback, get your input, and hear your questions and be able to answer them. And if you have a question, then it's quite likely that other people will be wondering the same thing. So it's really valuable to type in the question. And then when we answer it, we'll be able to help you and help everyone else as well. So please type in everything that you're curious about. And just while you're doing that, We'll have a recording, a replay of this up on our YouTube channel. That's youtube.com/user/embarcadero-technet. You're always welcome to contact me. I'm david.millington@embarcadero.com. And a few useful links on screen as well that would be valuable to read. First is a great overview of CMake. Then there's our documentation on our DocWiki. You can easily find that when Googling just for DocWiki using CMake with C++ Builder, but the URL is up there anyway. That is comprehensive documentation. Should cover everything. But of course, you're welcome to contact us if it doesn't. Finally, there are 2 blog posts by Jeff Preshing. He's not affiliated with us. These are just really great CMake blog posts that give you a sound foundation in understanding CMake projects and CMake scripting language. So with that, we'll move on to questions.